So let's see this question of a GATE 2024. This was a very conceptual question and very detailed question. If you know everything about pre-stress concrete, then only you can solve this question. So some of the questions of the GATE 2024 were also tricky. So this was one of the tricky question. What it is asking, first of all, let us discuss and then we will solve this question. It is saying an inverted T-shaped concrete beam is there. So T beam is inverted. This means that the flange part will be at the bottom. This means that the flange part will be at the bottom and the web part will be at the top. And with centroidal axis XX subjected to effective pre-stressing force of 1000 kilonewton. So starting force of pre-stressing is 1000 kilonewton. This is given. Now it is saying that it is acting at the bottom kern point of the beam cross section. Bottom kern point. What is the meaning of kern point? First of all, you must know. If you know the meaning of kern point, my dear students, if you know the meaning of kern point, then only you will be able to solve this question. What is the meaning of kern point? We will see. But first of all, let's discuss the whole question. Also consider an identical concrete beam B2. One beam is B1, another beam is B2. This is B1 beam. This beam is B1. And you have to consider another beam which is beam B2 with same grade of concrete but without any pre-stressing force. So there will be an identical beam. There will be same beam B2 here, same beam B2 here, but this will not have, this beam will not have, I will make this beam here. This B2 beam will not have the pre-stressing force. This B2 beam will not have the pre-stressing force. So this is your B2 beam and it will not have any pre-stressing force, which means there will be no eccentricity here. This is your B2 beam. In this beam there is no eccentricity. In this beam there will be no pre-stressing. Okay, so this is your beam B2. Now what is saying? Now it is saying, let us discuss what it is saying. Now let us discuss what it is saying. Okay, so it is saying that the additional cracking moment in kilonewton meter that can be carried by the beam B1 in comparison to the beam B2 is rounded off to the nearest integer. So what it is asking, it is saying that suppose the moment of resistance of this beam without cracking is M1. M1 is the moment of resistance of this beam. Moment of resistance of this beam without cracking. What is cracking we will discuss. And M2 is the moment of resistance of this beam, the beam without any pre-stressing. Let's say M2 is the moment of resistance of this beam. So you are being asked the value of M1 minus M2. This question is asking the difference between these two moments. The moment of resistance of beam with pre-stressing and the moment of resistance of beam without pre-stressing, the difference of these two moments is asking in this question. So how to proceed? How we will go ahead? How we will solve this question? हम कैसे आगे बढ़ेंगे भाई? So first of all, you must know that this is not a symmetric beam. This is a non-symmetric beam, which means the section modulus at top and bottom will be different. First of all, we will calculate the section modulus, because whenever we are talking about the moment of resistance, we must know the section modulus. So what we will do, we will calculate the section modulus first. We want to calculate this value, but for this we will calculate section modulus first. Always remember, whenever we have to calculate moment of resistance, we have to calculate section modulus. So we are calculating section modulus first. So first of all, we are calculating section modulus at top. Section modulus. We will first calculate at top. At top, the section modulus ZT will be, at top the section modulus ZT will be I by Y top. I is the moment of inertia, that is not given obviously, upon Y top. Y top is, this is the value of Y top, 2H by 3. And at bottom, the section modulus ZB, ZB means section modulus at bottom, both beam B1 and B2 will have same section modulus at top and same section modulus at bottom. So ZT is the section modulus at top here and also top here. Here the section modulus will be ZT. And at bottom here, in this beam, the section modulus will be ZB and the same section modulus ZB will be here. This will be Z bottom. Z top, Z bottom will be different, but here Z top and here Z top, these Z top will be same, these Z bottom will be same because the beam is same. So ZB will be I by Y bottom. Y bottom is H by 3. So what is the relation between ZT and ZB? Let's see. What is the relation between ZT and ZB? Let's see. Let's see the relation between ZT and ZB. So if we will calculate the ratio of ZT by ZB, so what will happen? The value of ZT by ZB will be I by 2H by 3 upon I by H by 3. So this will come out to be 1 by 2. So here we can say that ZB is equal to 2 times ZT. ZB is equal to 2 times ZT. This is the first relation. Will this be used in the solution? Definitely this solution will be used because we have not started the calculation of M1 and M2. We have to calculate M1 and M2, but before calculating M1 and M2, we should know the section modulus. Second thing, one statement is given here. The statement is at the Kern point. The pre-stressing is at the Kern point. It is written here that the pre-stressing at Kern point. What is the Kern point? Kern point is that point where we are applying if we are applying the compressive force, means pre-stressing force, there will be no tensile stress at the top. So when we are applying the pre-stressing force only, not moment. Once we are applying the pre-stressing force only, we are not applying the moment. When we are applying the pre-stressing force, there will be no tensile stress in the section. So where tensile stress can develop? If we are applying pre-stressing force here, so at bottom compression will be applied, but at top there will be tensile stress. So if the force is at the Kern point, there will be no tensile stress. There will be no tensile stress at top. Because the loading is at Kern point, because the pre-stressing is at Kern point. Pre-stress is at Kern point. Because the pre-stressing is at Kern point, then there will be no tensile stress at top. So sigma top will be 0. But when? Sigma top will be 0 when there is no moment applied, only pre-stressing is there. So at the top, when only pre-stressing is there, at the top the stress will be P by A due to compressive force, P by A stress, and minus P into E by Z due to movement of this pre-stressing force, P into E, and that will be equal to 0. If the load is at Kern point, there will be no tensile stress at top. So when we will calculate this P by A, this will be Z top because we are calculating at top. P by A will be equal to PE by ZT. So P and P will be cancelling out, and here ZT will be equal to, here we will calculate ZT, Z top will be A into E, which means E into A. So if ZT is E into A, ZB is 2ZT. So Z bottom, the bottom section modulus will be 2 into EA. So this will be the equation of your section modulus in terms of equation of section modulus in terms of E and A. Now you can easily calculate the value of M1 and M2. So this question was lengthy. First of all, you have to calculate ZT and ZB, the value of ZT and ZB with respect to E and A, and then we can calculate M1 and M2. Now we have to calculate moment of resistance of this beam up to what condition? Up to cracking condition. So at cracking, when the cracking will appear at cracking, what will happen? Yeah, yeah, without any cracking, or we can say that without any cracking, okay, because it is written here without any cracking. So let's see. So at cracking moment, when the cracking moment will come, that is M1 in beam for beam B1. At cracking, when the cracking moment will develop, the stress at the tensile fiber will be FCR. So whenever M1 moment is applicable in beam B1, the stress at the bottom, because the moment is applied, when the moment is applied, the bottom fiber will show the tensile stress. So the stress at the bottom will be negative FCR. So the stress at the bottom will be P by A plus P into E by Z bottom, which you know that is 2 into E into A, minus M1 by Z bottom, because the stress we are calculating at bottom should be equal to minus FCR. Minus FCR, why we are calculating minus FCR? Because the stress is tensile. At tensile stress, the cracking will develop. So at the bottom of the beam B1, when the stress, the overall stress due to moment is minus FCR, which means tensile stress of FCR, then the cracking will develop. And if we will talk about, for beam B2, so for beam B2, what will happen? For beam B2, if we will talk about, let me add another page. So at cracking moment for beam B2, at cracking moment for beam B2. So beam B2 has cracking moment or moment of resistance. Cracking moment or moment of resistance, we can say it as cracking moment also. Cracking moment. So whenever the cracking moment of beam M2 will be applicable, so here at bottom fiber there will be a tensile stress of minus FCR. When beam 2 will crack, it will have a tensile stress of minus FCR. So in beam 2, whenever cracking moment M2 is applicable for beam 2, so the stress will be P by A plus P into E by Z bottom minus M2 by Z bottom. That will be equal to minus FCR. In beam 2, that will be minus FCR. Okay, now there is no pre-stressing. In beam 2. So there will be no P force. P will be 0 because there is no pre-stressing in beam 2. It is written here that in beam 2 there is the beam with same grade of concrete but without any pre-stressing force. So in beam 2 this P term will be 0. When the P term is 0, this term will be 0. Only minus M2 by ZB will be minus FCR. So this will be the equation for beam 2 because there is no pre-stressing. This is equation 1. This is equation number. Let's say this equation number 2. This is the equation number 1. So what will happen? Now what we will do? We will subtract equation number 1 with equation number 2. So now what we can say? Now equation 2 minus equation 1. So minus M2 by Z bottom. Here this will be minus P by A. Minus P into E by Z bottom and plus M1 by ZB plus M1 by Z bottom should be equal to, here this is minus FCR, and when you will do minus of minus FCR, that will be plus FCR. So minus FCR and plus FCR will become 0. This will become 0. This will cancel out. So now what we can say? This will be M1 minus M2 upon ZB minus P by A minus P into E upon ZB. That will be equal to 0. This term we will put that 0 wala side, so this will become n plus. So here this will be equal to and this will become plus. This ZB will be multiplied here. So what will happen? So this will become P into ZB upon A and plus P into E. This ZB will be multiplied that. So M1 minus M2 will become P into ZB upon A plus PE. Now what is the value of ZB? We have calculated ZB value as 2EA. So we will put this value here. So this will become P into 2EA upon A plus PE. So here A and A will cancel out. This will be cancelled out. So this value will become 2PE plus PE, which means this will be 3PE. Now we have to only put the value of P and E. M1 minus M2 we have to calculate. The difference between cracking moment of beam 1 and beam 2 we have to calculate. We have to put the value of P and E. P is 1000 kilonewton and E is given here. This is E, 100 mm. This is E given here, 100 mm, which means 0.1 meter. This is also, we can say 0.1 meter. So eccentricity is 0.1 meter and pre-stressing force is 1000 kilonewton. We will put this value here. So M1 minus M2 will become 3 into 1000 into 0.1 and eventually this will become 300 kilonewton. So the difference between cracking moment of these two beams is 300 kilonewton. Your answer will be 300. Anyone who has given answer 300, 299 or 301, 299 to 301, anyone has given answer between this 299 to 301, so that is considered correct by the gate. So you have to put the answer as 300 here. So the answer is, I will write down here, the answer is 300 because it is asked in integer and it is perfectly integer 300. In kilonewton it is asked, in kilonewton meter, sorry, because P into E is there, so this will be in kilonewton meter. So they have asked in kilonewton meter because this is movement, so this will be kilonewton meter. So 300 kilonewton meter will be the answer. They have given the answer as 299 to 301. So you have to give 300 as answer. So this was a very tricky question. Lengthy question was, this was also a lengthy question. So you need to understand that the current point is what is the cracking moment with pre-stressing, what is the cracking moment without pre-stressing. You have to understand the thing. So this was the solution of your complete question.